Hey guys, it's Vince. Today in this video, I'm going to be covering retrofits. If you're interested in doing a retrofit, this video is for you. I've been getting a lot of messages lately on how to perform a retrofit, and the typical question I get is, I have such and such machine. How do I go about retrofitting it? What parts do I need? And in this video, like I said, it's time now to cover it in a video so everybody's on the same page. Retrofit requirements, I just made some bullet points here in my Vinyl Master to basically just go over and keep my mind fresh on what we're going to discuss. Motor size is always first. If your machine is manual, you don't really have a motor size to work with. We'll have to discuss the chassis size, which will then help us both put our heads together and figure out the motor size for your machine. If you do have motors available on the machine, if it was already a CNC robot, the thing we need to do is try to match the size. Whether it be a NEMA 23, NEMA 24, NEMA 34, or NEMA 42, we need to go through and find out what size best fits the machine requirement that you have. And usually we always go up. I always try to go up at least 20% on a stock motor because it'll provide at least a little bit of side benefit as far as how your machine will perform. Again, stepper motors, and these are the typical type of retrofits I do and recommend for their simplicity. Stepper motors will bleed off torque the faster they go. If you go 20% more torque, you can turn up the speed a little more and still have enough output torque to sustain that speed. So again, that's a buffer I always go for. Once again, torque, you can see here I said both size and torque. And again, torque is just the ounce-inch production of the motor. We definitely want to stay within the stock range. If we want to go a little above that, like I just was discussing with the 20%, I highly recommend it because you're certainly not going to see a huge difference in price, but performance-wise, it will balance out the system really nice. So the next topic, number of required axes to be controlled. Guys, details count. If you're looking at a 3-axis machine and eventually you're looking at going to 4-axis, then the thing you need to realize is that you want to make sure that the design you choose as a controller will be able to support that expansion. If you buy a G540 and you're already using 4-axis, then the standard G540 will not be able to do it. You'll need another G540, or you'll need a system where you're going to actually have to go through and wire in a full controller where we're dealing with individual drives. Then we deal with a breakout board and so on and so forth. So look at your budget, look at what your plan is for the future. What do you intend on doing with this machine, as far as application, as far as the expansion, and as far as your business, because most guys are doing retrofits for their business. If it sustains it, it makes sense. Look at everything as in general. Because once we go on to the next stage here where we're discussing the size of the chassis, I'm going to tell you right now, that's going to dictate a lot of what a retrofit with multiple axis is always going to cost you. If you look at the fact and you look at you're really looking at a 3-axis system going to the fourth axis, you're going to require another stepper driver. You're going to require another motor. You're going to require, if it's a rotary axis, you'd require a rotary axis. You're going to require the mechanics for the rotary axis. These are all things that will have to be done, and you'll have to have acquired before you even, get to that point. So think about that. You're going to require motor mounts. You're going to require motor couplers. I mean, there's so many little minute details, and yet there's none of them that are minute enough that don't matter. Everything matters on a CNC, and anyone that owns one will tell you that. There is no non-prioritized item. There's nothing that is, oh, it doesn't really matter, I can buy. I mean, write down, I can't think of anything. I mean, honestly, there's nothing I can think of that can be subpar and you get away with it. That get away with it mentality gets you in trouble. So stay with what you know, in the sense of, okay, this is my expansion, this is where I'm looking at going, here's where I'm looking at my budget being. That being said, let's go on to the next topic, the size of the chassis. If you guys are picking up a used machine, and you can get some really good deals on some older equipment if it's used, be realistic. If you're picking up an old Bridgeport knee mill, okay, an average retrofit on a Bridgeport is going to run you between $2,000 and $3,000, and that's just a retrofit. Now, I have some guys out there saying, yeah, I could do it cheaper. Do it cheaper, but do it smart cheap. If you're going to do it cheaper, you better go around and you better research every part you put on that machine. If you're trying to use its old three-phase spindle, or any machine where you're using three-phase electric, be realistic. If you think you're going to mess around with three-phase, I'm telling you now, the codes in most states, they really justify you actually having an electrician doing it. So be realistic with that. I really want to clarify, and I cannot make this more clear, I totally recommend against anybody as a hobbyist or as their own technician messing around with three-phase electric if they are not fully comfortable with it. It was extremely lethal, and on top of that, it can easily start a fire. So please, everybody, proceed with caution and common sense, mainly common sense and then caution. But overall, be very, very open with the chassis, and as far as where your budget is. If your budget isn't going to support it, if you can pick up a Bridgeport for between $1,500 to maybe $2,500 on Craigslist or wherever you're going, auctions, a lot of auctions are selling them. Be realistic as far as what the retrofit's going to cost. 98% of the guys I know are going NEMA 34s on Bridgeports. They're going, usually pro-grade drivers. I have a couple guys that may want to go with G540s. I don't recommend going too small of a driver system because, again, a chassis like that, you're still going to want speed at one point or another because that is designed as a commercial chassis. If you're using it for hobby use, I mean, it's totally up to you, the end user. But overall, most guys going that size with the Grizzlies and the Bridgeports, they're looking at commercial work. So, again, keep that in mind. Chassis is going to really dictate your budget. The smaller the chassis, you can do it on a smaller budget. The larger the chassis, of course, we're going with a larger budget. And be realistic. If you come to me and you think I'm going to do a large-scale chassis conversion and it's going to be, $800, guys, you might be able to buy a couple drives for that. Between the drives and motors, you might be okay. But when you're talking a full setup, it ain't happening for that. So just be realistic with yourself. And again, if you go to China and you want to get their drives and all that, you've already been warned in previous videos. All of my videos tell you support in this industry is most critical. So, and you find that out after the sale. You always do, and that's the thing that's really scary is after the sale you find out, oh man, I'm lucky if I can even get in touch with the guy I bought this stuff from. Or on top of that, manufacturers typically don't want to be bothered with, oh, I'm having troubleshooting issues with that. They don't have time for it, guys. They're there to sell parts. They don't care who they're selling to. Typically, they're selling to commercial environments who already have technicians, not guys who are rookies and, trying to get into this. So keep that in mind, again, when you're looking at doing a retrofit. We're going to get to the next point now. The spindle or cutter type you plan on using. Okay. If you guys are using, once again, a three-phase spindle because the unit came with its old-fashioned three-phase, you already know my feelings on that. I recommend staying with whatever type of cutter you can use and you can maintain yourself. Okay? The entire system, unless you're going to hire a technician, is going to be maintained by you. That means simple, stupid. Previous video. Okay, I did called Simple Stupid. Think simple, stupid. You better think that way because, again, the more complex you add to this system between all the different additional accessories you plan on adding and coolant and this and that, you can wire it up like a rocket ship as long as you can support it. Because if you can't, I'm telling you, you're making yourself extra work. And if you do have to troubleshoot anything, and at one point or another, I promise you, you will, think ahead. Take it from someone who knows. I'm not doing this as a hobby. I'm not sitting here. I'm telling you right now from a guy. I'm working with Boeing right now on a system design. I am telling you that there will come a time that you will have to service your system. Please make the smart choice and be able to do that and do it smoothly. You want to know your system to where I can go through, I can troubleshoot it, and that's when you know you've done the right thing, and it pays you back. It really does, because you'll be able to figure out the problem, move on, and say, man, I'm so glad I did this, instead of having to call somebody and And believe me, I hear it all the time. I get thank yous for that all the time because it'll pay off in the end, I promise. So once we get past spindle size, and again, think about the cabling. Think about, everything from your connectors, cabling, everything with your spindle. If you got an old three-phase and you want to go back to a regular, 220 volt spindle, I'm telling you now, that's probably for the most, I'd say it's about 85 to 90% of the novices. That's plenty enough to do most machining. Even if you're going commercial, you'll be good. You go 2, 3, max 4 kilowatt, usually you're fine. Okay, if you guys are going with lasers or you're going with plasma systems, and again, I deal with a lot of plasma conversions. Plasma, the torch itself is light, so your investment there to actually move the Z is usually much less because you don't require that kind of torque. But again, plasma systems are electrical nightmares. You're pulling so many amps. You're dealing with so many different electrical components. Everything with a plasma system, with the electronics, especially from the torch perspective, you are dealing with a lot of critical details. Okay, so keep that in mind. If you're doing a plasma system, take your time, go through each specific detail. And again, this is not just plasma. This converts over also if you're doing standard milling with a spindle, or again, even a laser is the same thing. You're dealing with a lot of electronic components. You want to make sure every detail, right down to what plug type you're using. Are you using aviation connectors? Are you using straight up, I have some guys that want to use butt connectors, which I totally I cannot tell you how much I disagree with that method. I mean, I've heard things, even this week I heard of somebody telling me they're running a 2.2 spindle, and 2.2 spindles usually run in about 10 amps normal usage at 220, and they're wired it with 18 gauge motor cable. Guys, please, every detail counts. If you're in doubt, I would rather you ask me something like that, or ask anybody if that makes sense to do, because if they tell you it does, I'm warning you, you're always better going to the next size cable. Minimum size cable I recommend for any spindle that runs 220 is 16 gauge. Okay, if you go 14, you're fine with that too. 14 gets so thick though, it becomes hard to work with. So always think in terms of your ability. If you have a question, you're better off asking. Go to a good source. If you have to call a manufacturer, you can ask that question. They will typically answer that. Okay, but overall, be very careful with certain choices you make, because like I said, with electrical, it's sometimes those type of choices where, it's running now with the 18 gauge and everything's good. As soon as that wire heats up, that's how fires start. Okay, the wire is too small a gauge, the amps are getting pulled, it generates more heat. Eventually, it gets to the point where the casing fails and you get an arc, and guess what? You're calling the fire department. So I'm telling you now, this entire, I guess I should say, niche is not something that you should take lightly. Every specific detail counts. And again, safety is always priority. Please listen to what I'm saying, research what I'm saying. I'm doing these videos to help. I really do care about your well-being, because I know what your overall goal is, mostly to make profit. That's what we're all doing. We're trying to, survive. We're trying to have our businesses, and we want them to thrive. Do it right. Don't cut your nose to spite your face and try to save a buck on silly things because you don't know or because you're guessing. Take the time and research it. Believe me, it'll pay off in the end. So once we got your spindle type and your cutter type, the type of motors, excuse me, the machine is currently using, stepper or servo. Well, we're back to this dilemma topic again. Guys, I go through this question all the time. Should I use servos? Should I use steppers? Realistically, if you're by yourself and you don't know, and 9 out of 10 of the guys that I sell to, I have to be honest, I don't care if you're an engineer. I've worked with many engineers. I don't care what your topic is, or your title is, as far as, if you've been in CNC for 30 years in commercial grade equipment. If you yourself have never maintained or built a fully functional CNC manufacturing robot, I recommend steppers. Steppers and servos are going to produce virtually the same result for somebody who has never built or maintained a CNC. And why I say that is, if you really think about it logically, Okay, and I say this comparison all the time because it's true. Okay, think about this. If you cut apart and I cut apart, and you've got, let's say you got steppers and I got servos, okay, and the tolerance on that part are the same, and the end product result is the same, guess what? You paid less and you did it right. That's all it is. You're not going to see a huge difference with servos. I get told all the time, well, what about missteps? And what about the missteps are because your controller is receiving signals most of the time as far as EMI noise that will interfere with a data signal. Now, that's not always the case if you're using cheap controllers. If you're buying a $30 drive from overseas, which again, TB560, if you're buying that, expect to have issues. Expect to have issues. Logically speaking, you are not going to purchase a high quality controller for $30 to $40, guys, especially a multi-axis unit. Come on. We need to use common sense. And again, you want to use, that type of logic on everything with this system. So if you're okay with going with the larger budget, if you're okay with actually setting up a servo-based system which requires more understanding of what you're doing, are you going to get more accuracy? You're going to get more accuracy if you know how to get it out of the machine. Is that accuracy going to be required for your application? That is the question, because if you're not going to see a difference in the parts you're creating, guess what? You're just buying it to say, hey, I've got servos on my machine. And does that make financial sense? It doesn't to me. Again, commercial companies I'm working with, like I said, I'm working on a project with Boeing engineers right now, and they're choosing stepper motors, guys. Okay, stepper motors for Boeing, stepper motors. I work with Tesla. I did one of their systems as well with an engineer for them. Again, they went with stepper motors. I'm telling you right now, that you're better off going with a stepper motor if you've never ever built a machine or you're maintaining it yourself. Now, there are some guys who say, hell with this guy says, I'm going to go with servos. You, the end user, have the best choice. Overall price for dollar for machining capability, steppers will always beat servos hand down. Okay, if you're looking at price as far as time saved without having to troubleshoot, because believe me, if you've never set up servos as far as going in and again on a full-scale retrofit, you could be dealing with PLCs. If you're not used to that, it can get extremely costly, especially if you have to call in a specialist. That's why most factories have their own technicians. If someone's running a Haas mill, you can guarantee they've got a tech that services that Haas mill. So again, from a full-scale perspective, think like that. Always think, what can I service myself? What do I need? What tolerance levels am I working with? If I'm working with 3 to 5 thousandths, if I'm working with 1 to 5 thousandths, steppers are going to be right there. Okay? Are they going to, I get guys say to me, well, they're not as smooth, and they're not this, and they're not that. Show me a part that you made, and show me a part that someone else made. And if they're the same, if the tolerances are the same, because here's the thing, servos and steppers are the muscle of the machine. Okay, that's all they are. If the machine itself that they're connected to is not set up properly, I don't care if it's a servo machine or a stepper-based machine, you're going to get sloppy results. Okay, guys, it's just a motor. That's all it is. Either one of them is just a motor. Don't put more emphasis on the factor that, that's like saying, your arms and your legs, that's what makes up your body. It doesn't work that way. Your body makes up your body when it's all interconnected. It's not one specific part. CNC, like I said, every detail counts. They are important, your muscle, but it's not the end-all be-all. Once it's connected to that machine, it's trammed properly. The machine doesn't have EMI because you took the time, you did it right. All cables are shielded. All drains are connected to earth grounds. The machine is earth grounded. You're going to get amazing results as long as you put the time in and the detail to get there. So again, which way you want to go. A lot of times guys will tell me too their machines are using servos and they want to go to steppers. I recommend that. Most of the time it's going to be the cheaper alternative. I just did a retrofit for a commercial-based company. I did a video on it on the pro-grade machine I did for a plasma system. They were utilizing servo motors. They were about $1,100 a piece, guys. $1,100 a piece, and we went over to a NEMA 42 stepper, And again, easy conversion, double the amount of available torque. So again, really it's the same size motor platform. He doubled the amount of torque, which means again he's going to have more speed because as we already discussed, I usually go for a 20% buffer as far as torque, but in this case we went double because the price was right on. And in that case, like I said, you're not going to see that much of a difference, especially when we're dealing with the tolerances we're dealing with. If you're in 1 to 5 thousandths, a stepper on a calibrated tram machine that's set up properly, all the bearings are smooth, all your mechanics are smooth, you're going to be very, very happy with the results. Okay? Next topic, required hardware to convert the chassis. Please stop messaging me. What hardware do I need to convert your chassis? The reason I don't want you messaging me about that question is each chassis is individual. Okay, there's no way if you're converting a lathe that I'm going to know exactly what you're going to need to convert because I may not have that lathe or be familiar with it. So I'm telling you right now, each individual machine that you're looking at converting will require a different amount of hardware. Use logic about that. If you have a lathe and you want to convert a lathe, you're going to require motor mounts to convert the lathe, what size motor mounts for the standoffs that come off the actual mechanics of the chassis. You're going to have to go through that too. You will have to engineer some of this process, some of this entire hardware for your system if nothing exists for it. If you go online and you find out that there's nothing out that exists for this chassis and you want to convert your own chassis, guess what? You're engineering it because there's no other way you're going to just go online and be able to find it. So you're going to have to go and put the parts together, take measurements. And again, look into the fact, are you capable of doing this? And be honest with yourself, because if you're going to half-ass it, it'll show up in the end. Believe me, every time somebody half-asses something on this equipment, I don't care if it's a retrofit, I don't care if it's a build, it will eventually sneak up and bite them in the ass. And I promise you, this is a fact. I mean, I'm telling you everything you need to know in this video with retrofits. You can apply everything I've said in all my other videos to this, and it's factual. Everything I'm telling you, don't cut corners. Again, follow every detail as if you do this detail wrong, you won't even turn the system on. Keep it in that perspective. So, again, go over your hardware and be realistic. Am I capable of finding standoffs for my motors? Am I capable of taking accurate measurements to give my standoffs the proper amount of clearing and spacing for my actual couplers? Is there any way I can even mount this? I mean, I have to mount the standoffs to the machine. Am I capable of actually doing that? You know, do I have the tooling? Do I have the time to do this? If you don't, odds are it's not a good idea to tackle the retrofit. I can't tell you how many guys have told me, you know, I've been doing a retrofit now for about a year and a half to 2 years, and it's just been sitting in the garage because I haven't had time to really dial it in and, you know, get everything I needed to do it. Guys, don't be that guy. Don't be that guy that sits there and, you know, they go into a project and they don't finish it. I deal with that all the time with guys. Do one project, start small, and work that momentum until it's completed. Okay? I mean, when I build a controller for whoever it is, I give them a lead time, and I know my lead time is bleeding through, and I will go through and work a little bit each time till I dial that in, and I know I get there. It's the same principle. Always do that with your projects, especially something like this. Take your time. There's no rush. Do it right. I promise it'll pay off. So, again, required hardware to convert the chassis, standoffs, screws, spacings, measurements, possible weld positions if you're going to weld up a spacer. I get a lot of guys that are great welders that want to do that. You can do it in a lot of different ways. Just once again, keep in mind of what it takes. Do some Google research. Once again, I'm not a big forum guy, but do some research to see if anybody else has converted the chassis. If you're trying to find out if it's already been done, it's not a bad idea to say, okay, I can go online. Maybe someone offers something that I can use in terms of, okay, they've already done it. I wonder what they use. It does not mean it's going to be 100% to your machine. And I've seen that a lot. I talk about that a lot with kits when guys are buying plans and, you know, I'm going to buy the plans and I'm instantly going to know how to build a machine. It doesn't work that way, guys. Every machine has its own caveats, even if it's the same machine. You might be using the same bearing he is and you get a bad bearing, or your transmission is not as smooth. Think about that. Each one is individual. Each beast is individual. You have to look and really think about all those details. So again, once you've acquired all of this knowledge about these requirements, and again, some questions you're going to have, I expect that. Motor size, like I said, if the machine is manual, you're going to get back with me and say, look, it doesn't have any motors, but right now I'm looking at converting a manual machine. We'll discuss your options and we can go from there. I can usually guide you that way, and like I said, we'll put our heads together, we'll come up with something. But the rest of this, before you contact me about a retrofit, if you do contact me and don't see this video, I'm gonna send you right to it, because again, I think there's this will explain a retrofit process in a nutshell. And again, for my guys out there who already know this, most of them are shaking their head and saying he's right. Most of my guys, my past clients will tell you, there's never an easy process with CNC, especially if you've never done it before. If you're looking at your first project as a retrofit, be prepared, because it is a large, large elephant to eat. So again, I hope this video has helped. Once again, my name is Vince. eDealers Direct Automation, that's my eBay store. You'll see eDealers Direct. If you have questions, you can email me at storm213@gmail.com. And again, I'll do my best to help you. Again, you can also message me on YouTube. Once again, I thank you guys. Take care.